Okay, let's talk about dividing fractions. Let's talk about our first example, okay? All right, so how many fourths, right, are in two wholes? Okay. So what I'm gonna do first, grab the wrong one, is I'm actually gonna label each of my fourths. Cool. So you'll notice too how many fourths are in two. Up here I have two holes. Okay, they're both shaded. And when I break those holes into fourths, I end up with 1, 2, 3, 4, 5, 6, 7, 8 fourths. Okay. Now there's a way to solve this that we're going to talk about soon, so that it makes a little bit more sense about how we got to this. I'm just shaded in. That way we can see that if we were to take two of these whole groups and divide it into fourths, we'd end up with 8 of those fourths. Okay? Let's keep going. It says 3/4 divided by 2. Okay. We'll put our two groups there. This will become 3/8. And I'm going to talk to you about why in just a moment. Actually, I'll go ahead and just explain it now. When you're dividing fractions, there's a technique you're supposed to use called keep, change, flip. Okay, when you use that, you keep the first fraction, which is our 3/4 here. You change your division sign into a multiplication sign. So now it should look like this. And remember that 2 is always over 1, but in this case they want you to flip it. So instead of 2 over 1, it's 1 over 2. Then when you multiply straight across, you end up with 3 over 8, which is what our answer is. Okay? With that said, since our new denominator is 8th, that's exactly what all of these are actually broken up into, 8ths. Now, they want to know, what that looks like. So, okay. We'll shade in, let's say, each group is supposed to be 3/8. So I'm going to shade in my first 3 here. Okay, and I'm going to say that these 3/8 here is one group. I'm going to say the next 3/8 is another group. One group, and I'll shade these in too. And that is like our visual example of what that looks like, right? So 3/4, 1, 2, 3. If we divide that by 2, 1, 2 are two groups. What does that give us? That gives us 3/8. Here's 1, 2, 3. That's one group. 1, 2, 3. 3/8. That's the second group. All right, let's keep on keeping on. Slide this up just a little bit. Okay, so when we have 5/6 divided by 2, remember that we keep flip change. So it's 5, 6. Well, I'll rewrite it. So it's really 5, 6 times 1 over 2, which gives us 5 over 12. So when 5/6 is divided into 2 groups, how large is each group? Well, up here I'm going to have my sixths. Remember, our first fraction was 5/6. So we do need the actual sixths individually, but we're only shading in 5 of them because that's what our original fraction said. All right. And obviously, based on our answer, our solution, you see that our new denominator is 12ths. So all of these are 1/12. 1/12, 1/12, 1/12, 1/12. Now, again, we're only focusing on the 2 groups, okay? So we should have each group being shaded in essentially 5 at a time, okay? 1, 2, 3, 4, 5. That's going to be one group, because when I divided my 5/6 by my 2, I ended up with 5/12. So here's one group. And I'll shade in 1, 2, 3, 4, 5. And as you can see, the shading on the bottom fraction bar matches the shading on the top fraction bar, which tells you that what we have is true and equivalent. And my second 5/12 is going to be my other group, my second group. And so that's what it should look like. Number 2, maybe not as busy, okay? Here, again, we still have our whole number over 1. And again, we're still going to KCF. We're still going to keep, change, flip. So we're going to keep that first fraction. We're going to change our division sign to multiplication, and we're going to flip our second fraction, aka the reciprocal. So instead of 1 over 3, it's 3 over 1. When we multiply straight across, we get 6 over 1, or just 6. And we can say that how many thirds, we're getting that from here, are in 2. We're getting that from our original first fraction. This can be labeled as 1 whole. That's one group. Or, that's 1 whole, sorry. This can be labeled as the second whole. And then, again, we divided by thirds. So each one of these boxes is represented by 1/3. Now, we are going to shade in 1 whole here. And of course, I should have 3/3 to make 1 whole. 1/3, 2/3, 3/3. 3/3 makes 1 whole. When our numerator and our denominator match, that is 1 whole. Our second whole here, again, is comprised of 3's, or thirds. 1/3, 2/3, 3/3. 3 over 3 is 1 whole. All right, let's go to the second page. When we get to this second page, you'll see I filled out a couple things already, and these are our basic rules when it comes to, sorry, a little too high. Basic rules when it comes to dividing fractions, okay? You change a mixed number to an improper fraction. We do that with our walk around Texas technique. You rewrite the first fraction if you have to. We'll do that for number 3, and you'll see what I'm talking about. You change the division to multiplication, and you find the reciprocal, and that's going to be our flip. Then you multiply and you simplify. All right, let's get into it. So here it's 6 over 1, but we're going to rewrite it. We have 6 over 1 divided by 3/4. We're going to keep, change, flip. 6 over 1. Change that to multiplication. Change this to 4 over 3. Now again, before we actually cross multiply and divide, you always want to try to simplify first, if it's possible. And you do that by finding common factors. 4 and 1 don't share a common factor, but 3 and 6 do, and that common factor is 3. 3 goes into itself once, 3 goes into 6 twice. You multiply straight across, and you should end up with 8 over 1, or just 8. Let's work on number 4. All right, number 4. We're going to keep our first fraction. We're going to change our division sign to a multiplication sign. And remember that a whole number as a fraction is a whole number over 1. But we're not going to keep it as 3 over 1. We're going to flip that and find its reciprocal, so it's actually going to be 1 over 3. Now here there are no common factors between our numbers, so we're just going to multiply straight across. And we're going to end up with 2 over 15, and we're done there. Here we're going to keep our first fraction, but in order to actually use the fraction that we have, which in this case is a mixed number, we have to do our technique, which is to walk around Texas. So let's go ahead and do that. 4 times 2 is 8. 8 plus 3 is 11, and we keep our denominator is the same, so we should have 11 over 4 divided by, really it should be 5 over 1. Of course, we're going to rewrite this as 11 over 4. We're going to change our division sign to a multiplication, and we're going to flip that 5 over 1 to 1 over 5. When we multiply straight across, we should end up with 11 over 20, and that can no longer be simplified. Therefore, that's our final answer. All right, let's keep on keeping on, y'all. We're on our last little problem here. So here, these are just kind of thought bubbles they want you to think about as you're dividing fractions, especially in real world situations, right? Ask yourself, what is actually being split up, right? What's being divided? What value represents the number of the groups? And what value represents the size of the groups? Also think about does your solution make sense in the context of the situation? So if you're starting with a larger number and that's essentially your total and all your answer choices are smaller, you know, you shouldn't be doing an operation where the number, your total, gets bigger. So that's kind of what they're talking about. It just has to make sense within the context of the word problem. Cool. Let's work on number 6. Number 6, it says Kayla works at a pizza place and the tomato sauce cans contain 14 cups of sauce. If each medium pizza uses 3/5 of a cup, how many medium pizzas can Kayla make with 1 can of tomato sauce? Okay, so let's talk about what they're giving us, right? What do we actually know? Well, we know that it takes 3/5 of a cup, I guess, of sauce. That's fine, we can be more specific, to make 1 medium pizza. So we can say per pizza because they told us it was going to be medium. We can also say that there are 14 cups of sauce per can. So in every single can of sauce, it contains 14 cups of sauce, even though it only takes 3/5 of a cup to make one medium pizza. Well, let's talk about what we need to know. Basically, what we need to know is how many medium pizzas can Kayla make with 1 can of sauce. Okay, so that's what we need to know. How many medium pizzas can Kayla make with 1 can of sauce? Can of sauce. Okay, cool. So basically, we're going to take that 1 can of sauce, which contains 14 cups, and we're going to divide it by the amount of fractional cups it makes to make 1 medium pizza, which is, in this case, is going to be 3/5, okay? So remember, our whole number is really over 1. And this is a great place to utilize our strategy of keep, change, flip. So we're going to keep our first fraction, which is 14 over 1. We're going to change our division sign to multiplication. And we're going to flip our 3/5 to 5 over 3. Now, there are no common factors here, so we will multiply straight across. This is going to give us, let's see, 5 times 4 is 20. Carry the 2. 5 times 1 is 5, plus 2 is 7, so that's going to be 70 over 3. Obviously, we cannot leave it like this, so let's go ahead and continue to simplify through division. We'll do it on this side here. 70 divided by 3. 3 can go into 7 twice. That's going to give us 6. 7 minus 6 is 1. Bring down our 0. That's 10. 3 can go into 10 3 times. That's 9. 1 decimal 0, and it's going to repeat over and over and over again. So essentially what this is going to end up being is she can make 23.33 continued, or if you know what this means, 23 1/3 medium pizzas is the amount of pizzas that she can make. All right. Well, again, this is dividing fractions 1. I hope this was helpful. I'll see you guys in the next video.